Very warm welcome. This is the agenda for today. We're going to introduce the webinar very shortly. I will introduce myself too. I have a co-host, René, who is joining here today on a digital way too. So he will introduce himself too. As we all have different backgrounds and maybe different functions within the company or different experience with process analytics, we will just have a small what it's all about. So a bit of theory, let's say. Then we'll dive into a client case, which is the main part of the seminar. I think it's always, or we think it's always a good idea to showcase the success factors and the benefits of a process analytics project or project in general by going to a client case, which we will keep anonymous. And then afterwards, there is a conclusion and a Q&A session to go through your questions or remarks. So let me first maybe introduce myself. I'm Rosez. I'm senior consultant within Aebischer for 1 year. I've been working on different operational excellence projects in the past year, always with a digital touch, and this is why I'm in the digital community also. I've been focusing mainly on coaching daily management and introducing continuous improvement loops within maintenance departments, but also in fabrication. So my main focus last year was on maintenance, and I've been doing some project management too for a few companies. Next to me in the digital seat is René, who is also co-hosting this webinar, and I'll pass the word to René to introduce himself.
Thank you, Glenn. Good morning, everybody. My name is René Aebischer. I'm with Aebischer since 7 years. I'm a principal, head of the digital practice in Belgium, and also a member of the group analytics network of Aebischer worldwide group. I'm focusing in the, let's say, digital analytics project on helping clients to scope their project and also defining the financial impact and the benefits of those kind of projects.
Thank you very much, René. So the goal of this webinar and the fascinating world of process analytics, we will start first with understanding what it is all about. We will go through some key success factors, some pitfalls based on the client case, and then we'll have a case where we go through to showcase the benefits and the approach which we used in this case. So first of all, process analytics, where is it all about? What we often see if we look at processes and if people talk about their processes, then it's the left side of this slide. So it's a linear series of activities if it's documented in the traditional way. But if we look at it and if we unravel a little bit how processes are followed or executed in reality, then it's much more complex. Then it's an intersection of a lot of roads, like the picture on the right side. And this can be due to many reasons. First of all, it could be that people are a bit creative with the way they execute the process, and in time, new sideways or new roads exist towards the same or a different end. This is maybe also the case why within shifts, if you work in shift, that different shifts have different performances because the process might be executed differently. Secondly, it might be that there are some process inefficiencies during time, during the evolvement of time, due to, for example, external factors. There are some inefficiencies which make you alter the flow of your process. And thirdly, maybe your process was not designed in the beginning to capture every exception. This is not a bad thing because you might have an exception management which helps you to tackle these exceptions, but new roads might exist. And so in reality, we often see a lot of roads, a lot of variations of a process. And this is why within process analytics, we try to use the process-related data, objective process-related data, the reality, capturing the reality with the objective of analyzing it and optimizing its performance, the performance of the process. And so there are different levels in process analytics. First of all, you have descriptive analytics. It's a basic start. You take a look at all the data you have within a certain process or a certain process step. You look at it historically, and for example, through process mining, you try to unravel And this is an example. You try to unravel how the process is being done, being executed in reality. So this figure or this illustration, it's based on a real case that we did for a purchasing process. And we try to find out which activities were not done as it was conceived and were not adding value to the process, and which work streams, which value streams were executed but didn't add value. So in this way, we tried also to optimize the material flow of the purchasing process. So in this case, I think if you took a look at this slide, it's very similar to the one that I showed previously, where you see on the left side how we think the process works and the linear series of activities, and on the right side we see how it is done in reality. So this is descriptive analytics. The next step is predictive analytics. We will discover scenarios of what could happen in the future, and then we can act upon it, and then we can make an informed decision. This could be via live simulation. The case, for example, that I will go through just after this introduction to process analytics will be an example of predictive analytics. If we go one step further, then we are talking about prescriptive analytics. This will show us what will or should happen in the future, and then the machine can make an informed decision. An example of a process that we did, of a project that we did with a client, was within a pharma company. There was a sensor in place to take a look at the weight and the volume of bottles. And based on the volume, and it's a really small example, but it's still prescriptive analytics. And based on the volume, an informed decision was made by the machine, and another process was followed, and the handling process was different, because we know in advance if there is a deviation in the volume, in the weight, then it would give problems in the end towards quality of the product. So these are the three different levels, let's say, from descriptive, predictive to prescriptive analytics that we are seeing and that we are using, applying in projects. And so the case will dive into the middle one, the predictive analytics, with a small portion of prescriptive analytics. And so I'll pass the word to René for a bit of activation of activating.
For the next.
Yes.
Thank you for this insight in what process analytics and the main blocks that might, so to speak, increase a bit the level of maturity in terms of process analytics. Maybe it's time for a word with the audience here. Glenn, if we can ask you, please, dear participant, to take your mobile phone and either to flash the QR code that you will see here on the right side of the slide, or to enter the access code on Menti that you have on the left side. So please take your mobile phone and access Menti, either through the A or the B way of doing it. And you will see a couple of questions that are pretty much related to just what Glenn expected and what Glenn was telling you on the different levels of process analytics. So we'll leave you a couple of minutes. Glenn, can you see on Menti who is replying? So we'll have 3 people. So maybe good. We'll still wait. The questions that you are asked are pretty much related to the benefits that you want to take out of process analytics and the different level of process analytics. So I see in the meeting 21 participants. We have 7 answers. I propose a bit to wait till we have somewhere in the middle. So if we take the assumption that the rest of you adhere with the answer provided by 12 people here, we can see that it's pretty much on a second level of maturity that you are expecting your benefits. So it's not only creating process transparency, but it's also going much more than that. say by detecting losses and bottlenecks, certainly in the current context about energy and scarcity of energy prices and access to material and resources. This is something that is very relevant for most of the clients we are talking to. And even you go a bit further by simulating what if scenario, allowing you to take some decision and to make some decision on the future way you want to design or to improve your processes. Also pretty much interesting is the last one, finding optimal configuration, which means you really act on the different functions and on different variable that impacts your process in order to tune that and to optimize that. Meaning that at the audience, we have pretty much a good level of maturity regarding process analytics. Thank you for that. Glenn, up to you.
Thank you, René, for this. Let me go through the client case now. So we have set the basis of process analytics, what it is all about. During the client case, I will first give a small introduction. I will talk about the burning platform. So this case is based on a real pain, on a real problem within the company, within a certain process. So it's always good to start from that. What do we want to achieve? What is the objective of this process analytics project? We'll talk you through the approach and go a bit deeper on the technical side. And then we'll end this case study by going through the key success factors and the benefits. So first of all, I want to make an analogy by comparing process analytics with driving a car or steering processes by driving a car. I think we would never drive a car like this, but we have a lot of information, a lot of data within our car, and to steer our car or to steer the process, in this case, we are not using all the relevant data. We are maybe using our past experience, and we know maybe the road, we know the car, and so we are using our past experience to drive the car, to steer the process without any feedback loop. A next step would be that we drive the car and take a look behind, that we are using the back mirror in order to steer our process or to steer our car in the right direction. Of course, there is always a delay because you're taking a look in the back mirror. We would never drive a car like this, but we often steer process like this. We take a look what happened in the past, even with a delay, and we are modifying, we are controlling our process. So ideally, and that's also the case was designed like this to have a predictive model in going to autonomous driving cars. But even just a step before, if you are driving a car and you see the car notices that a car is braking before you, it will see the lights flashing and it will make the link that the car is approaching, that we have to brake. So there might be different options. There might be the option of just giving a signal that you have to brake or braking itself. And so we are having this evolution towards autonomous driving cars. And the big challenge here is, and I think everybody can relate to that, we are used to driving our car in the way we do, and we are used to steer the process and control the process like we do, but we have to have confidence. We have to change our way of thinking. We have to have confidence in the model that is predicting the future, is predicting which parameters we need to change to adapt and to steer our process. So due to the simulation, due to different sensors, there are multiple sensors used for driving autonomous cars. We are optimizing our driving behavior and we are taking a step further. We are looking in front of us. But the main message for me here is that we have to think about the change impact on people too, on process engineers, for example, because we have to have confidence in the process, in the model that is being used and the data that is used in the project. So the client where we are talking about here is a tier one supplier of the automotive, 3.5 billion revenues, 12,000 employees worldwide. The product where we are talking about here is a high voltage heater. So it's a specific product that is in ramp up phase because it's used in electric car, in e-vehicles in general, so electric cars and hybrid cars, to heat up the elements of the car, but also just the interior of your car. And it's a 12-step process, and process step, which is in scope, is the coating carousel. So it's somewhere more at the end of the process, and we are taking this process step in scope because there was a real pain, and this is the burning platform. So define, and it's a Q6X factor, define a clear objective based on real pain. So the problem here at hand was a high scrap rate. So the quality was not enough. In this case, it was a complex process, and often we are using process analytics within complex processes that we don't understand by traditional methods. So of course, the process engineers, they had a good idea, a good understanding of how the process works, how this coating carousel works. There was a lot of data, there were a lot of sensors, but there was still a high scrap rate of around 5%. So they had the goal to increase it a lot, because the increasing demand had to decrease it a lot, because the increasing demand would have as a consequence that we lose market share if we are not able to deliver. There were a lot of contracts in place with Tesla, with BMW, etc., to deliver certain quantities, even with the ramp up phase, or with the ramp up of quantity in perspective in the future, we would never be able to deliver these quantities. So in this case, a real pain, a clear objective, decreasing the high scrap rate, improving the quality. So this is always a good idea to start with a clear objective and everybody aligns. So which approach did we take in this case? And it's most of the time it's kind of the same framework for different process analytics projects. First of all, we have an exploration phase. We try to understand the process. We try to understand the reality of the process, how it is really executed. So we are not taking a look at the one-way highway, but we are taking a look at all the highways. We try to understand the process by taking a look at the data structures to understand how the data is captured, how it is processed, how it is put at our disposition to be analyzed. We formulate hypotheses and we come up maybe with new ideas, but we understand also the past projects that have been done and maybe didn't result in the objective of this project. Secondly, the next step is we build a prototype. We try to we model our process. This is a very important step to understand the root causes of the low quality. In this case, for example, we figured out that there were micro leakages in one of the pressure pipes, and so the PLC didn't take up these micro leakages, but they had a big impact on the process. And so by analyzing in our model, by checking which parameters have which effect on the quality, on the final result, we found out that these micro leakages had quite some impact. So this is only one of the possible root causes that were discovered during this phase. So a lot of the added value was during these first two steps, but we had an offline model. Offline model means that it's not in the process. So it's always with a delay that we have the information about the process and that we adapt the parameters. But it's based on the reality, on the different highways, remembering the picture that I showed just previously. So this was 3 months. Most of the time it's 2 to 5 to 6 months that we are in this in these two phases. And then we have the step to an online model. So the big advantage here is to go to a quick response time. You have your model in your process. So based on the simulation, based on the optimization, your parameters will be altered, will be modified to improve your quality during your process. So there is less of a delay. In this case, it took 6 months. Most of the time it takes 5 to 8 months, a little bit different on depending on your data architecture. In this case, and this is why I will go through a technical zoom just afterwards, the data structure was not in place to be able to incorporate the online model. So these are the 3 steps. And if we take a look at the technical part, due to historical reasons, we see a very specific data architecture. So first of all, you have the PLC, which has the different sensors coming in and the actors like adjusting the speed, maybe modifying the granulates, which are put in the process, etc. So this is the PLC, which pushes after every batch. So in fact, this data architecture was not in place to be able to capture the data in a series production. So in this case, after each batch, a CSV file was put on a network drive, then afterwards on an Access database, and then to an SQL server where we could make analysis on. So this is historically grown, and it's often something we see in a lot of companies. But of course, there is a multiplication of data. There is a high delay because only after each batch and maybe even after each hour, we could do analysis on the data and could steer the process. So in practical, every day there was an analysis done, so there was a high latency. What we introduced here was to connect the PLC immediately to the database, to a local database. So it was really stored next to the machine on a local computer, because we wanted to have a quick feedback loop. So the feedback loop to our PLC to adapt the speed, adapt the different parameters of the process based on our sensors, based on our prediction model. This was done in a very, very short 0.1 second feedback cycle. And in this case, the model was kept fixed for one month. And then after a month, the owner of the model, which was then the process engineer, they made adaptations to the prediction model in order to optimize even better your process. So, but during 1 month, it was fixed, the model. And then after a month, we adapted the model to be able to respond even better to the reality of the process. So this is the data architecture which was in place and the new solution that we provided. And this is also the reason why it took around 6 months to implement this. And so what are the key success factors of this project? First of all, like I already told you, define a clear objective. I will dive into the results just afterwards, but make sure that everybody understands as the same terminology about what are we talking about, which project is it, which process is in scope, what are we trying to achieve, and make it based on a real pain. Second one, and it's also related to the image I showed you about steering a car and driving a car. And if we are evolving to autonomously driving cars, we have to consider also the impact on people from a change perspective, from having confidence in the model, but also you will see that afterwards the handling the scrap is not at the high the scrap is not on the high level there anymore. So handling the scrap will be done in a different way. There will be less people involved to handle the scrap, so we can reuse some of the people, some of the operators, to think about our process and to launch continuous improvement projects, for example, to think about improvements on the line itself. And then the third one is making a reference to the previous slide I showed, is taking into account your current maturity level. So depending on the IT infrastructure, depending on the amount of data that's available, we might have to do some preliminary studies to see which sensors we need to introduce in the process in order to capture the right data. Because in this case, we had a lot of data. It was a quite new process. They didn't understand all the parameters very, very well, but there was a lot of data at our disposition. So we had a good basis to work on. But this is not always the case. So these are 3 key success factors that we took from this project. And so if we dive into the first one, what we saw and what we could achieve was a 60% scrap reduction, which was enormous, going from 5 to 2%, and which impacted immediately the EBITDA. Since we were in a ramp-up phase, the expected gains were 2 million, because there will be a multiplication of amounts in the upcoming years. Of course, electric vehicles are booming at the moment. And then we would also avoid penalty, because if we wouldn't deliver the quantities which were stipulated in the contract, then otherwise we would have penalties. And also freeing up capacity, like I told you, consider the impact on people. the quality control will also be different. There will be an inline quality control. At the end, the handling of the scrap, the operators. So there is a big impact on them too. And by reducing the scrap, we free up capacity. This was the client case. I will pass the word to René for concluding the seminar.
Probably not for concluding immediately, but for giving a sort of a wrap up. If you go to the next slide, Glenn. So basically, well, the next one, thank you. Definitely the age of process improvement based on paper documents and interviews and Excel is over. We need to reap the benefits of the data you can take out of your production systems. Those are the much more reliable sources of information than the one that you can find out and not taking into account the data. This means very concretely that you need to capture, enrich, and analyze your data. This is about data analytics, or at least the source of data analytics. But it's not only a data and a tech game only. I mean, the data insights give you then very reliable information on opportunity for process improvement, which means that you have to adapt your processes, but also maintain the model you have done, because what Glenn explained in developing the process or developing the project was just like building something that captures the data and provided information. The second part of the project was embed that in the processes. So there will be an effort also in maintaining the model, so as it always is in sync, I would say, with the reality and with the process as it evolves. It's also about embarking people and educating them, giving trust to the data. Accepting the fact that sometimes the data can be more reliable, or the prediction of a model could be more reliable than the good old knowledge that operators on the floor do have. However, it is important, but sometimes it provides much more reliable insights. And the last part is probably an important one, also seeing the enormous range of opportunities in data analysis. It's about scoping correctly. Because all the variables that have an impact on a process do not really deliver the highest benefit. So quantifying the benefits, scoping correctly, and finding the impact on the P&L or on the balance sheet is something important also, and we take this into account. So this is pretty much, I would say, the way we do process analytics at Efeso, and also based on the example illustrated by Glenn. Thank you very much. So I guess it's now time for questions. You can either raise your question or voice your question, I would say, or raise your question via the chat. We are at your disposal. I see one question in the chat that says, is there a risk of adapting your model too much to a worsening condition of your production line? Glenn?
I think it's a very good question, because the ownership of the model still stays with the process engineer, who has to know this model very well and to understand it very well. So make sure that you don't adapt your model too much to worsening conditions. This means also that you need to adapt your predictive preventive maintenance plan. Use your sensor data in a good way to check the conditions of your machinery, to keep it in the basic conditions, because otherwise you have indeed the risk of modifying your model too much to worsening conditions of your machinery. So make sure that your predictive preventive maintenance plan uses these sensor data too and is adapted.
Okay,
I hope this answered the question.
I guess so. I see another question from Stefan. Stefan, do you want to voice over your question, or should I read on the chat?
I can voice over, that's no problem.
Thank you, Stefan.
So concern is regarding the resources necessary for the automation team setup needed to guide such change, measurement of change in an organization which has local production sites and also has a HQ. But what's the right balance and the right key skills necessary to set up such a team prior to embarking on such a change?
Yeah, thank you, Stefan. The connection was not pretty good, so I will read also the question for Glenn, because it's I think one for Glenn, who is working currently in an engineering team at local level. So the question is there an advice on organizational design necessary for automation, for the automation team on the local plant level or at group level? Glenn, you're currently on site also with a client at the engineering team. Can you answer this one?
Hey, Stefan.
Yeah.
Sorry. I didn't catch the question very well. So could you maybe specify a little bit more?
It's in the chat, Glenn.
Yeah.
I might give it a first trial.
Yeah.
I think, Stefan, the answer is on both level. There is one necessary for an organizational design at the local plant level, because they can connect and collect and enrich the data you receive from your different operation processes. There is probably also, we see also a tendency to develop such teams at corporate level, or say at group level, just because the tooling and the way analytics is deployed and the way we can reflect and analyze and model the data is something that could be taken up at the group level to provide such kind of, I would say, governance and toolkits and best practices to the different local teams. However, the data is local. Another reason for deploying that at a group level is that some data are captured also at group level. I'm thinking about some sales and scheduling data that sometimes also are important for local level to take into account. So from an organizational perspective and from a data capturing perspective, it makes sense to have it at both levels. Is that a good answer for your? Is that an answer for your question, Stefan?
Yeah, that's already a part of the answer to my question. So it's interesting to understand that on both levels, sufficient skills and different skills are necessary.
Absolutely. Absolutely. Thank you. I have a question from Bijan.
Yes.
Bijan, Glenn, do you take up?
I can take it up. So if I
Yeah.
understand correctly, is the question at what stage of the process map or the process, the different phases are we going to include these human elements? And I think, yeah, that's the key success factor here is from the beginning having this change embedded in your project. And I think it's, and we think at the VESO that it is just a necessity if you do this kind of operational excellence project, because it's an operational excellence project, that you include a digital stream, but not only the digital stream, but at the same time also the human factor, the change that you consider it from the beginning. So this means including everybody who is immediately impacted by this project, by the process, and to not only on the management level, get them involved, because they have to stand behind your project a lot, but also on an operator level, because they will see you on the work floor, they will see you analyzing the data, so they have to know, okay, what are we doing exactly, and take them into this project together. This makes the change easier afterwards, because their capabilities or their what is expected from them will change. This impacts a lot their daily work, and so they're afterwards, after the project and during the project, other input from them is also expected. So take them as from the first step in your project, very concretely talk to them, have them included, and then I mean even operators, your process engineers, have them included in a core team where you have representatives of all these groups, and make sure there is a communication plan, that you communicate about it, that you make sure that you have the same goals, the same objectives, and that you think about change from the beginning. And we think that this is very crucial to maintain the same standards over time. So, Bijan, I hope this answered a bit your question.
All right, I see a thumbs up. Okay, thank you. I have one question in the chat from André, pretty interesting one. André wants the operators to be in the driving seat of the car, like he said, with a question: how does process analytics connect with autonomous maintenance? This is a very interesting question. I'll probably give a start on the answer on that one, André, and if we can engage in a conversation on that one. Yes, operators are in the driving seat of the processes and of the manufacturing. So what we provide here is just like augmented assistance, like we say sometimes. It is assistance by data driving. It's not the fact that, well, it's probably also a choice that you have to make. For some processes that you have what we say an automated curative action made on your process, like the case on the pharma that Glenn explained, where you can stop the process or you can ask the machine to stop the next stage of the process because you know that the variation between the, I would say, the golden batch, in this case it was, and the actual composition of the batch was not okay. So the variation was out of range, and at that moment the operator had not to do something. It improves also when you have off shift and you have continuous production. Where sometimes operator have delay in intervening in the machine. So it is augmented assistance instead of augmented reality for the operator. And it's a choice you have to make on letting, let's say, analytics and the data drive or decide about the process, or let the operator decide about that. But it's a complex, it's a very interesting and engaging conversation we have with some clients on the level of autonomy and level of automatic curative action that we let the machine decide. André, you want to add something to that?
Maybe a small addition, René. What we also believe is crucial if we talk about autonomous maintenance, autonomous management, is taking a look at your current situation, because autonomous management and autonomous maintenance can only work if your machinery, if your process is in basic conditions. So start with this. You can have a lot of data, you can have a lot of things going on and analyze a lot, but just make sure that you follow the different steps. We have a complete route about how to implement autonomous maintenance, how indeed understand your car, make sure that your car is also clean, that you can see all the defects, because this is the first start. And you can have a lot of sensors, but if your machine is not in basic conditions, if you don't understand how it should work, then you can have a lot of data at your disposition, but it will not make autonomous maintenance a success. So there is a route with different steps. Make sure you don't skip the first steps and immediately jump to one of the middle or the last steps. So I think this is really important to consider too.
Yeah, thank you for adding that to the question. Should you have questions in your mind after this session, please forward them to us. We will revert with an answer or contact you to engage in a conversation where we can go more in the details of your question and on the answers we provided. So I guess we come to the end of this webinar. We pretty much have a busy agenda, I guess. So I thank you very much for attending this webinar. Hopefully it brings you something that you can take concretely in your operational and daily life. And thank you for attending. Wish you a very nice day. Bye-bye.
Thank you very much.